the screen share. Let's actually go here. So I want to begin class as usual with a couple of review questions. And so last week we covered Python functions, which is basically a block of code or some lines of code that we can group together, that we can use again and again in wherever we want. And sometimes this takes in different kinds of inputs. Sometimes it gives you different kinds of outputs, or maybe it doesn't output anything at all. It depends on the function. But that's what we started discussing last week. And so I have a couple of review questions as well as going over the homework, just so we're on the same page again before going on to some more, I'd say, advanced functions in Python. So the first is just kind of, do you remember this? What is the special Python keyword that always is at the start of any function we write? So it's just something special in Python. It's 3 letters. What is it? So let me open my chat. Yeah. Correct, Andrew. So again, anyone feel free to put in chat or unmute. But yeah, DEF, short for define is what you can think. We define our functions. And so can anyone tell me, let's see, we have 5 students, so let's get someone ahead. Thank you, Andrew, but let's get someone else. What goes after the DEF? So we have DEF, we have a space. What goes in that next section when we're writing a function? So we're defining some new function. It does something. And we started out with DEF. Andrew told us we have to start with DEF. But what goes after that? We have something here, and then we have another something, and then we have a colon, and then we have the body here. So this first blank, I'd say. I'm gonna try calling on someone, but thank you for volunteering, Andrew. I'm just gonna go at the top of my participants list. Alex, do you remember what goes after the DEF, the def?
I actually forgot this part.
No problem. Then Jennifer, do you remember what goes after the DEF?
I forgot to.
It's all right. So we're defining a function. So what do we need to provide? We have to provide the name of the function. So what goes in the next spot right after the DEF is the name of the function. So this can be anything really. Basically anything you can call a variable, you can also call a function. So you can define a function x, although people usually don't do that. People usually define their functions with some sort of name that tells you what it's doing. So let's define some sort of function like myfunc. I kind of went against my own rule. It doesn't really tell you what it's doing, but that's just because it's some imaginary function that I came up with. And so this last blank, that's before the colon, I'm just gonna give it away this time. It is the inputs to your function. And so even if you don't have any inputs, so even if your function works perfectly fine, doesn't need any inputs given in, you still need parentheses. Any single function that you write will have parentheses before the colon. But if your function takes in inputs, that's where it goes, inside the parentheses. So maybe this one takes in nothing, and I just put nothing there. Or maybe I want a function that takes in 2 arguments. And so I can say, like in A, comma in B. So input A, input B, for example. And so these are just 2 variables that I can use inside the body now. And these are things that would be passed in. So when you're using the function, someone would provide you with 2 values, and they would be stored in those 2 different variables. So that's defining a function. You always start with DEF. After the DEF, you have your function name. After the function name, you have your inputs or your parameters. And even if you don't have any parameters, you still need the parentheses. You still need to put something there. After that is nothing special. You have your colon just to show that you have a block of code. You have a section of code that's following that belongs together. So that's why you have the colon. And then you have the body of the function, whatever it's doing. The second review question is about default values. So looking at the function I have right now, this def myfunc in A in B, this does not have any default values. Can anyone tell me how to modify this to have a value, for example? So I want in B to have a default value of 5, for example. Can anyone tell me how I would do that, first of all? So I want to modify this line of code so that the second parameter in B has a default value. Yep, thank you, Andrew. So you just say in B equals your default value. So I said it's going to be 5 just randomly. So that's adding a default value, right? So you have some sort of inputs to your function. And now the second input has a default value, which means that if someone doesn't supply a value to you, if someone only gives you one input, then you just say, okay, I know I have this default, I have this like fallback, right? Like if no one tells me what it should be, I just have some value to go off of already, and I'll just use that, right? But as soon as someone does give you 2 values, you just say, okay, I don't care about the default. I'm going to use what they told me to use, right? It's like your last resort. If you don't have any other choice, you'll just use a default value instead of just like giving up, right? If you didn't have a default value, if it was just like this before, you always have to provide 2 values, because if you only provide one, it doesn't know what to do, right? Like it takes in 2 inputs, you only gave it 1, that's not okay. But as soon as you have a default value, then it's kind of okay with 1 argument. It works with 2, it works with 1. It doesn't work with 0, it doesn't work with 50. You have to be 1 or 2 in this case. But it kind of gives you a little bit more flexibility, right? That was the 2 review questions. I know we had a little bit of trouble, and I was looking at the homework, and it seems like we had a little bit of trouble with that as well. So before I talk about the homework, I have a quick straw poll, which is basically just an anonymous polling method for myself. So I made this poll. If you can click the link in the chat to go to this page, you can vote on one of the options. And I just want to know how the homework went. So I didn't have as many people completing the homework as I would have hoped. So that's why I want to understand, like, did you not understand the instructions? Did you not know how to solve it? Did you just forget about it? Or is there something else? So I'm going to go to the results. Again, this is completely anonymous. I see the overall responses, but I don't know who chose what. So don't worry about people finding out. Don't worry about other students knowing what you put. Yeah, I think we have 6 students in the Zoom right now. So I do want to wait until we have 6 votes. I just want everyone to kind of fill out this survey. Again, the link is in the chat. Looks like right now I only have 3 votes in. Okay. Oops. I'm gonna talk about the homework in the meantime, but I really do want to try to get everyone to fill out that survey. Just multiple choice, select your answer, hit submit. Um, yeah. Anyway, the homework was 2 questions. The first one had kind of a story behind it. You're the HR department, which is the department that manages all the employees, and you need to figure out how much to pay your employees based on how much they make per hour and how many hours they worked, right? That would have been very simple, and the solution is pretty simple, but there's one kind of trick, and it involves something that we covered in the review, which was the default value. So in the instructions, it said you should take in an hourly rate and how many hours they worked. But if you don't have the hourly rate, you just use a default value of $11 per hour, right? And then that's the function that you need to write and create. And so I have the solutions here. So here is what the function looks like. It's very short. Let me zoom in a little bit though. So again, based on the review, DEF is just your keyword. It's just what every single function in Python starts out with. Here's the name of my function. I very creatively just called it myfunc, not very interesting. You could have called this whatever you wanted. Right? And then the inputs to this, well, based on the instructions, you have to know how many hours the person worked and also their rate. Right? And then this is where the default value comes in. We said by default, if you don't have a rate provided, you just use $11 per hour as your default. And so that's why I say rate equals 11. The inside of the function, I split it into 2 lines. You definitely could have made it just one. All it is hours times rate, right? How many hours you worked multiplied by how much you make per hour gives you how much you made. And then I calculate this and store it into a variable. And then this last line is how you return values. You literally just say return the value. And what this does is when you use this function, you provide it 2 inputs, and now it provides you with some sort of output. You generally would store this into some sort of variable, but you can also use it directly, which you see here. So this is where I'm testing it out in the next cell. Just some random test cases I came up with, but I called it on 1/6. So you work for 1 hour and you make $6 per hour, and it should print out 6. This one should print out 45, so on, so on. The last 2 are checking the default values. So if I only provide 1 number instead of 2, then it should use the default rate of $11 per hour and calculate 22 and 440 in this case. So if I just run this, you can see the output matches what was expected, right? These are my expected results, just calculating it by hand. These are the results calling my functions. And as long as they match up, that means my function is doing what I think it should be doing, right? So again, the function is very simple. Def, name of the function, 2 inputs in this case with a default value for one of them. And then the body is just multiplying the 2 inputs and returning the result. The second part of the homework was a little bit more involved, but I think you did something similar already in the past. So it shouldn't have been too much extra work. But I just wanted you to write a function to calculate the median of a list. So a list of numbers, I want you to find the median or the middle value, not the average, the median, right? And so there's a couple of tricks. The first one is I said that the list is in any order. So you probably want to sort the list first, right? So here is one way of sorting the list. We covered 2 ways at least on how to sort lists, but this is the one I chose. So first I take my random list and I sort it. And then I have 2 different options. If the length is even, then the median's a little bit more difficult to calculate, right? Because now it's like the average of two values, and that's what's going on here. I calculate the left middle and the right middle, basically the two values I need to average, and then I just calculate the average. If the length was not even, then it's a little bit simpler. All I have to do is find the middle, and then the median is that middle value. And at the end, I just return either one of these medians, depending on if it was even or odd. And I can do some test cases. I actually have a test case that does not pass. So these three all pass. This one actually has a problem with it. And I will post this to Classroom along with the Python, pure Python version as well. I encourage you to take a look if you have the time and figure out why this one doesn't work and maybe a way to fix the function so that it does work. Go back to the poll. Looks like I still only have 3 responses to the straw poll. So please, I really do want everyone to fill this out if possible. Again, I don't know what you select. So don't worry about me finding out or any downsides or anything. It's just purely so I have an idea of what I should do in the future. Should I give less homework? Should I give more instructions? Do I need to review more? Anything. I guess at this time, I would also appreciate if anyone has any feedback about the homework so far. Like, do they think the homework's boring? Do they want more homework? Or is the homework too difficult? Is the homework not matching what is being taught during the week? Anything like that would be helpful. So, okay, Andrew says more homework. Yeah, so since we're on the topic now, this is something that I did in Python 1, but there's a site, CodingBat, which is pretty good. And so I can put the link in chat again. I was looking over these, and I think all of these you should be able to do with what we covered so far. But for example, let's go to list 2 and sum 67. Here's kind of one sample problem. Return the sum of numbers in the array, except ignore sections of numbers starting with 6 and extending to the next 7. So this is like actually, this one I'd say is a little bit tricky. So might take a little bit of time, but here you can see what it's asking for you. It's asking for a function, right? It's giving you the start of the function. Def sum 6, 7, input is nums, which is your list of numbers. And then you just need to write what goes inside. Like, how do you do this function? Right? They described what it should do. They showed you kind of the outputs it should provide, and you need to write it. So looking at this, I'd start with the level 1s, the string 1, list 1, logic 1, these 3. If you think these are too easy, then start doing the level 2s as well. And if you want something more than this, this doesn't have too many questions, like only about 6 per section. If you run out of this or you don't want to do this, just let me know and I can find other problems to give you. The only thing is this is not as going to be, it's not going to be as closely related to what we're covering in class, but it should be good practice. So the straw poll, not sure if it's not updating. Okay, oh, it looks like I have 5 votes. Maybe it wasn't updating in time, but didn't know how to solve the problem. Seems like the most popular. Yeah, so I would say for that, if you don't know how to solve the problem, if you get stuck, or even if you don't know how to get started, leave a comment in Google Classroom. So when you do the submission, there should be a place to leave a sort of comment to the instructor. And when you do that, I get a notification, I get an email, and I know that someone asked a question. I can come in and help. And so if the thing that you're struggling with is not understanding how to do the problem, um, please reach out to me. Secondarily, I'd say try to start the homework early because it's less uh, it's not as difficult if the material's still fresh, right? Like it's gonna be the easiest to do right after class. You probably don't want to do it right after class, and I understand. But if you want to do it, let's say Tuesday or Wednesday, to get an early start, so that it's still kind of fresh in your mind, that might help as well. And also gives me more time to work with you if you do have questions. Because if you message me Monday at 3 o'clock, I don't have much time between then and the start of class to help you. Um, but yeah, I'm definitely available. Just leave a comment, shoot me an email, and I'll get back to you. Yeah. I don't have anything else I want to cover for homework today. Although, does anyone have any questions about either how these solutions worked, um, the format, the homework, any clarifications I should make? All right. So I don't hear anything or see anything in chat. In that case, I can move on to the PowerPoints for today. Although if any questions come up, please just leave a message in chat or speak up. Don't worry about interrupting. One last thing before we get to the slides is if you can open up PyCharm, open up a Google Colab notebook, whatever you use to write Python, that will be helpful, and I'll be copy pasting some code into the chat for you to run and just to play around with as well today. But if we get to the first slide, we're talking about functions still. And this first one is still kind of review. It's showing you an example of default values again. So here, what this is doing is has a function called last first. It takes in someone's first name, takes in someone's last name, and takes in a separator. And what it does is it formats a string for you. It puts the last name first. That's why it's called last first, right? So it puts the last name, it puts the separator, and then it puts the first name, right? So it combines that into one string, stores it into result, and then returns the value, right? So notice it has 3 arguments: first name, last name, separator. But separator has a default value. The default value is a comma with a space, right? Because if you see names written like on books or papers, a lot of times it's last name, comma, space, the first name, right? So that's the default value because that's what you would want like 90% of the time, for example. You just want the comma space as the separator. But maybe there's the 10% where you want a hyphen. Maybe you just want a space, you don't want the comma. Maybe you want something really crazy, like 5 Z's in a row, right? You want the power to do that. So you have that separator argument. You couldn't put any separator you want. But if you're lazy, you can just use the default value. You just have to supply the first and last name, which you see here. So we can do last first Tom and Smith, or Tom Smith, which would give you Smith, comma, space, Tom. Default values. That's what it's talking about here. The function has 3 parameters, but if you look here, we only provide 2. The reason we can do that is because the third one kind of knows what to do without being told, right? It knows, hey, if no one tells me what to be, I'll just be the comma space. Getting to kind of the new stuff, the default value is evaluated only once during the program's run. And this usually is not that important. Usually you don't think about this much, but it does make a difference when the default value is some sort of mutable object. Does anyone remember what mutable means? What does mute mean? It's able to be mute. What does that mean? Changeable, yeah. Thank you, Andrew. So mutable just means changeable. It means once you create it, you can still change it after. So examples that we covered is list. That's the only thing we covered really. Lists we said were mutable because how do you add things to a list? You append. And what does appending do? It changes the list, right? It adds a new thing to it. A list has to be mutable. If it wasn't, then it'd be kind of useless, right? Well, if a list isn't mutable, then you have to have all the values there in the first place. And an immutable list is a tuple, basically. But this is saying if you have a list as a default value, this gets into some tricky areas where the default value is only set once. And so if you change the default value inside the function, it changes forever, right? And so we can see this here. And let me take this, copy paste this into chat. I also have it on a Google Colab notebook right here. Let's go here. Well, first of all, just running the default value stuff. This is the last first function where you can provide Tom, Smith, and it will print out Smith, Tom, right? But I can also call it with all three. And so for example, if I don't want the comma space, I can put the hyphen to separate it. And that will provide me with a different output. This is the code I put into Zoom chat where it's doing the default value with this function. And what the function does, if we look at it, it's called def. Well, it's called f. It takes in two inputs, a and l, where l is going to be some sort of list and a is going to be some sort of value. And what does it do? It appends a to l and then returns it. Right? And so l starts off as an empty list. We use this function first time here, f of 1. So because we only provide one input, we only provide one, the number 1, it uses the default value for the second input. It uses the default value for L. And so you can think of A as being the number 1, L as this empty list. And so we do L dot append A. So that empty list now becomes the list containing 1 because we appended a value to it. And then we'd return the list. So this should print out the list 1, right? Which it does right here. But this is where being mutable has some kind of nasty side effects, right? Because if we call the function again, using the default value again, it doesn't really do what you might expect, right? You might expect just a list containing 2, but that's not what it does. What it does instead is the list containing 1 and 2. That's because when we called it the first time, we've appended 1 to L. So this default value is no longer an empty list. The default value is now a list containing the number 1 in it. And so we append 2 to it, we return it, that's why we get 1, 2. And then again, if we call the function again, now it's gonna return 1, 2, 3, right? Like the previous function calls have changed how the function works now, right? Which is usually not what you want. And so this is usually like something you should avoid. You should usually avoid using mutable values as default values. Technically, I guess you could come up with some maybe clever ways of using this to your advantage, but most of the time it's just confusing. And even if it's not confusing to you, it would be confusing to someone reading the code for the first time. And so you should avoid this, right? It's just a caveat, a warning. So that's default values with mutable default values. one kind of definition thing before we move on to the next thing is the idea of keyword arguments and what we've seen so far, which is positional arguments. And so what does that mean, positional versus keyword? Well, let's look at positional first, because that's what we've been doing so far. A good example is this last first function, right? Notice we defined the last first function to take in 3 parameters: first name, last name, and a separator. Right? Notice it's that order: first name, last name, separator. And so when we call the function, for example, when we call the function here, we provide 3 values: Jack, Leo, and a hyphen or a dash. Right? And it knows what value to assign to which input because of the position. This is why it's called a positional argument. The first argument in the position is the first input. The second input in the position is the second parameter. The third, right? It matches up directly. First to first, second to second, third to third. Not really surprising. This is what we've seen so far, positional arguments. However, you can do something a little bit weird, I would say. You can call it using keyword arguments. And so in this case, the position no longer matters. I can provide the last name first and then the first name second, right? I can change the order. I can provide the separator first even. And what that looks like is like this. Still having print, still calling the function, which is last first. And then I have 3 arguments. Let's do the last name first. So all I do is use the keyword last name, because that's what the parameter is called. And then I provide it a value, right? Equals, I'm gonna look at my Zoom chat. I'm gonna look at Alex, for example, Woo, right? And then I'll do first name equals Alex, and then maybe separator equals just a space, right? I can do this and it does still what you would expect it to do. It puts the last name, puts the separator, and then puts the first name, right? But notice the order of the arguments is weird, right? We defined it as first name, last name, separator, but we provided in a different order. We did last name, first name, separator, right? We swapped the order of these first 2 things, right? In this case, it's not super useful, but it's something that you can do. And when you do stuff like this, it's called keyword arguments, right? Notice one thing I don't want you to get confused. When you do something like separator equals space here versus separator equals comma space here, right? These look similar, but they're very different in what they're doing, right? What I've highlighted right now in this cell, this is defining the function, right? Notice this line is defining the function. So here, since we're defining the function, we're defining the default value here. Right? That's all we're doing. We're defining the default value. When we do separator equals blah, blah, blah here, this is different, right? We're done defining the function. We've already done that. Now we're using the function. We're calling the function. And so when you do separator equals space here, instead of defining a default value, you're providing a concrete value to pass in. Right? This is my input. I'm providing an input of space, right? Here, I'm providing an input of last name Wu. I'm providing an input of first name Alex, right? These are values like that you're using in the function. These are not default values. These are like specific values that you're using this specific time. It's not always going to be Alex Wu, right? Next time it could be Jack Leo, right? That's because here we're not doing default values. We're not defining anything. So it looks similar, but there's an important difference here between this separator equals and this separator equals. Right. So that by itself is not super interesting. Like why would we want to put the arguments in a random order? It can be useful in the sense that you want to make sure what you're doing is correct. Maybe someone else wrote this function and takes in two things, and you don't know if it's like A, B, or if it's B, A, right? You don't know the order. And so to be sure, you just use the keyword arguments. You just say the name of the input equals this, the name of that input equals that, right? And so you know for sure that you're providing the right values to the right inputs. Right. But this is also interesting in what we're going to cover next, which is basically an arbitrary number of these types of arguments, both positional and keyword arguments. And so that's what this slide is all about. The star args and the double star keyword arguments, right? So these you could just put in, right? You can see it right here. And so what it's doing is it's taking in kind of two inputs, but we'll see that it's not actually two. It's like basically any number you want. You could put infinite number of arguments here. You can put no arguments here. It's fine with both. The star is what makes it an arbitrary number, right? So it shouldn't be surprising because that's the only thing that looks different that we haven't seen so far, right? Like, why do we have this star? Right? And so if we look at the first one first, args, ignore this double star keyword arguments. This is defining an arbitrary number of positional arguments. So you can say this function takes in 5 things, it takes in 2 things, it takes in 10 things, it takes in no things. It doesn't really matter, right? You can say my fun A2 cat, or you can say my fun nothing, right? This is an arbitrary number. And what it does is, since it's some arbitrary number, you have to deal with it in a special way inside the function. Inside the function, when you're using this, like args, first you don't have the star anymore, right? The star is only when it's up here. When you're using it, you don't need the star, right? The star is not part of the name. The name is whatever is after the star. So when you're using it, it's basically a list. You can think of it like a list. It basically takes in all the arguments that you passed in, whether it's 10, whether it's 100, whether it's 0, and it puts them into a list. And then from then on, you can just do it, you can work with it just like any other list. You can loop through it, you can access maybe the third thing in the list, whatever. You can reverse it, you can sort it. It's just a list at that point, right? And so I have an example in the Google Colab I can show here. So this is a function that adds up an arbitrary number of inputs, right? And so the way I do arbitrary number of inputs is this star args right here, right? I do def mysum. So I'm defining a function that's called mysum. And then inside the parentheses, I have my inputs, which in this case is star args, or an arbitrary number of arguments. And then what does it do? Well, I start off with a total of 0, and then I loop through my list of arguments. For argument in args, I just add it to the total, right? Total equals total plus argument. I add it to my running total. And then at the end, once I've gone through all my different arguments, I just return total, right? It's finished adding things up. It's done to return. And here is where I've played around with it. So let me delete this a little bit. I can just add 2 numbers, 5 and 8, and it'll give me 13. Not very surprising. But I can also give it another number, maybe -4. And now it's going to give me 9. I can add more and more numbers, right? I can add 100, and now it's going to be 109, right? It's just an arbitrary number. I can even have no numbers, and it'll just give me 0 as by default. I can do 1 number, and it works fine, right? It works for any number of arguments. And so I'm also going to put this into the chat. You can play around with it, put whatever arguments you want in. Technically, this can also add strings, although it's not really defined to do that. But you can do like A, B, C, and it'll just add them up together, I think. Or, oh, no, you can't actually, because I defined total to be 0. But if you define total to be something else, then you could do that. That was not a good example. But if I go back to numbers, you can see it works just like how you want it to work. This is an example of the star args, but this is showing you that most of the time you will see it as star args, but the name of it is just any function, any variable name, right? By convention, by default, it's going to be star args, and that's what you should use like 90% of the time. If you have a specific reason, or if you really want to change it to some other name, you can do that, no problem. You can just call it whatever you would normally call a variable. So here, instead of doing star args, I just do star my args, right? A different name. The important thing here is not the name of it. The important thing here is the star. The star is doing all of the magic. The star is doing all the collecting the arbitrary number, putting it into a list, and then working with it later. That's the important thing. You need the star. The name of it is whatever. It's just a name. So here I do def var fun star my args, and then I just loop through it and I print it out. Yeah, so good question, Andrew. I'm gonna get to the double stars really shortly. But if we look at this one, you can see I can do var fun with a couple strings and it prints out all of them. I can do var fun with nothing and it prints out nothing. And I can also do var fun with 2 things and it'll print out the 2 things. Right? Is this an arbitrary number? You can also do like, this is gonna break, but you can also do like print r my args 1. Oops, typos everywhere. But you can also do like print my args 1. And it's gonna break for this one because there is no my args 1. So I'm just gonna comment that out. But if I run this, you can see it's printing out the second argument in both cases, U and B, right? It's essentially a list. I don't think it's actually a list. I can check type of it. I don't know off the top of my head, but if we just run it, okay, it's a tuple. So a tuple, if you remember, is just a list that can't be modified in the sense that you can't add things, you can't change what's inside of there, which makes sense because there's no good reason for you to change the parameters once it's already been passed in, right? Like it was passed in for a reason, it should be that value. There's no reason to change it. So that's why it puts into a tuple. And if you remember, tuples are a little bit faster. So that's another reason why it's a tuple. But for all intents and purposes, tuples and lists are basically the same in terms of how you work with them. But does anyone have any questions about this single star so far? We'll get to the double star after this. I will say it's pretty interesting, and I think you can see it's pretty powerful to do this arbitrary arguments thing. Although personally, in my experience programming in Python, there hasn't really been any cases where I've needed to do this, but it's definitely good to pay attention to. And a lot of times when you read documentation, which is when other people write code, give it to you, and then they write some notes in it. A lot of functions, if you look online, have this star args, star keyword arguments, double star keyword arguments. This is very common, so it's good to know about it. Yeah. All right. So that was star args or star anything. The important thing is the single star, which is putting basically a bunch of positional arguments together, right? Notice I put these inputs first, second, third, fourth, and then in my tuple, it's going to be first, second, third, fourth. So these are positional arguments. But I can also have an arbitrary number of keyword arguments, which is when it looks like this, right? When you have the argument equals some value, the argument equals some value, right? These are keyword arguments. And so I can have a function that takes in an arbitrary number of keyword arguments. And that's what the double star is for. The double star is for doing an arbitrary number of keyword arguments. And the way it does this is similar to the single star. But in this case, since it's a keyword argument, not only does it have a value, but it also has kind of a name, the keyword, right? And so you have to store both. So in this case, it's no longer a tuple. It's something else called a dictionary. And I think this is a good place to talk about dictionaries, given that we have a little bit of time. So if we just look at an example for now, let's just look at this one, the def my fun, which takes in both star args and double star keyword arguments. I can play around with this function. I can say my fun, like 1, 2. And this is only the args, right? Args is this tuple 1, 2. Keyword arguments is nothing. But as soon as I add a keyword argument, maybe like first equals I, now it's putting it into my keyword arguments, right? It's printing it out. I can put another keyword argument, second equals by, right? And so now I have 2 keyword arguments and I have 2 normal positional arguments. And so this function takes in basically any number of anything. It takes in any number of positional arguments. It takes in any number of keyword arguments. Okay. And so what I want to talk about here, and kind of the last thing I want to cover in class today, is how it's being stored. What is this? And so that brings us to Python dictionaries. And I'll go over a really quick explanation of what they are. So if we just write some code, I want to work with a dictionary. And a dictionary, if we think about it, not from a code standpoint right now, from just like a normal real life standpoint. When you look at a dictionary, what is it? Well, it's a book. It has a lot of words. It has a lot of definitions, right? Let's give this some sort of programming terminology. The words that you're looking up are keys, and the definition is the value. So you have a key and you have a value. You use the key to look up the value, right? In a dictionary, you have a specific word in mind, you look for the word, and then you find the definition associated with it, right? You have the word, you want the definition, right? In general, that's how you work with dictionaries. You have the key, you want the value that's associated with it. Another way to think about it is it's like a bunch of lockers, right? They're all locked. Each of the lockers has some sort of value stored inside the locker, but you need a specific key or to open each one, right? And so depending on what key someone gives you, you can access one of the different lockers, right? And unlock it and then get the value out of it. What you're interested in, what you want is the value, right? And so that's exactly what's being stored, how it's being stored here, right? These keyword arguments are being stored in a dictionary where you have a key and you have a value. The key is the keyword, right? That's why it's called a keyword, right? It's the name of the parameter right here. So when I say first equals high, first becomes the key. This is the keyword, it's the key. And so you can see first here. And then what it's equal to, the value, is the value in the dictionary, which you have a colon and you have the value. So you have your key You have your colon, you have your value. That's how it looks like when you print it out. This is not what it's going to look like when you are programming. This is just the graphical output, the print statement. But you can see you have your key, you have your value, and then you have your comma, which says, okay, I'm done with my first thing. Here's the second thing in my dictionary. And again, you have a key and you have a value. Right? I can change the value, right? Maybe first is now the number 5. And it will change the dictionary. Notice the key is still the same because it's still called first, right? The name of the keyword argument has not changed. So the key in the dictionary has not changed. But what has changed is the value. No longer high, now it's the number 5. Right? So hopefully the idea of a dictionary is not too confusing. You have keys and you have values. You use the keys to look up the values. Some examples of dictionaries in real life, besides a normal dictionary, like a phone book or your contacts list is kind of like a dictionary, right? Because the key in that case is the name of the contact or the name of the telephone book. And then the value is the phone number or the email or whatever in your contacts, right? You use the key to look at the value, right? Someone who wants to use it, they already know the key. They already know what key they're interested in. They just don't know what the value is yet. That's what you're for. That's what the dictionary is for, storing this mapping, right? They're connected to each other. And so if we go back to coding now, how do we do this like kind of in code? There's a couple ways. I'm just going to start off with the simplest way. I'm going to call my dictionary, I'm just going to call it the letter D. So an empty dictionary, to start off with, is shown by these curly braces. So you saw it here when it's being printed out, you have these curly braces. The curly braces are for dictionaries. So when I say D equals curly braces, this is creating an empty dictionary. And I can print it out, right? And so it's just an empty dictionary because I haven't put anything in there yet. So the question is, how do I put something into the dictionary? Well, that's actually very, very simple. All I do is the name of the dictionary, and then square brackets, almost like I'm accessing something in a list, right? You use square brackets for indexing. But instead of an index inside the square brackets, I have my key. So the key can be almost anything. Here, I'm going to call Jack, right? So the D with key Jack is equal to some value. So I'm going to say the name and the birth month, right? So my birth month is April, so it's 4, right? So D Jack equals 4. And then, well, I didn't print it out, but if I print out D again now, you can see the first time it was empty, and now it has a value in it. I put a value inside the dictionary, right? And that's what it's shown here. The name of the dictionary, and then you have to provide a key, and you have to provide a value. Right? The key goes inside the square brackets because that's what you're looking up, right? Like that's what you're using to look up values, right? Just like how normally you would put an index inside the square brackets. Well, why are you putting the index? The index is what you're using to look up some value. Here, we don't have indices anymore. We don't have indexes. We have keys. So you put the key inside the square brackets. So you have D square bracket, the key, and then you set it equal to some value. So here I'm putting it to 4. And now it shouldn't be too much of a surprise to access things from your dictionary. So we know how to put things in. How do we get things out of it? Or how do we look into the dictionary and find something out of it? Well, it's basically what we've done before. We just do the name of the dictionary and then the key that we're interested in. At this point, the dictionary only has one key. It has my name as the only key because that's the only thing we put into it. But here, we just use the key inside of square brackets to access the value, right? this will not print out Jack. It will print out whatever value is associated with it, right? Jack is the key. It's not really interesting. The interesting thing is the value, the 4, right? And so here, when I do D Jack, it prints out 4. I don't think many of you have experience with other programming languages yet, but if you go to other languages, you might hear the term dictionary flying around. You might hear the term map being thrown around. There's different types of maps, but I kind of like both terms, dictionary and map. Calling a dictionary makes it really clear, like based on a real world example. A dictionary, you have keys, you have values, you have words and definitions. Those are your keys and values. Yeah, correct, Andrew. Hash map is one example in Java and other languages. A map, I like that because you are creating a mapping. One thing maps to another, right? You have your key that maps to the value. So if I provide a key, you can provide me a value because they're linked together. They're mapped together. Right? So both names I like. I'll use dictionary because that's the term in Python. But if you look online and you find things about hash maps, tree maps, all different sorts of maps, it's the same thing. It's just a different language. And so why did we go through all of this? Well, it's just because when you do this double star keyword arguments, it puts it into a dictionary. Right? So when you do this double star keyword arguments and you provide an arbitrary number of keyword arguments, it stores it into a dictionary. And then you can just, inside the function, access it, do whatever you want with the arguments, right? Here, it's a little bit advanced, but here we're taking a keyword arguments. Notice the double stars. And then when you do a dictionary.items, it's basically giving you the keys and values. It's looping through them, right? And so looping through every single key and value, I just print it out. And so here, when I do AOE, I should change this from when I last taught. Well, now it's summer, but the location's still online. The time is 6 p.m. So updating this for this semester. You can see this function just takes the keyword arguments that you were given and does some fancy printing of it. Okay. So that's all I had for today's class. Just as a really quick recap, since it's fresh in our mind here, just covering some, I guess, more interesting, more advanced things with Python functions. Specifically, the first was working with the default values and what happens when you have a mutable default value, specifically like a list, right? When you have a default value, it's only evaluated, it's only set at the beginning of your program. So the first time you run it, it's set. Anytime after, it doesn't reset it. And so when you say it's a list, it's set to the empty list at the beginning. But if you modify it, if you change it, then it starts messing up later on. All right. And then the second thing is the arbitrary number of arguments, which we saw with star args and double star KW args, keyword arguments. Again, the name is not super important. You could call these whatever you want. What it is important is the stars. So a single star for positional arguments, double star for keyword arguments. Okay. Whatever you call the list or dictionary, the tuple or dictionary, sorry, doesn't matter. So let me just go back to slides so I can go over the homework. The homework for this week is a little bit interesting and maybe a little bit more fun. It's coming up writing a number guessing game. And I think this was kind of at the end of Python level 1. So if you have code, you can use that, but I do want you to update it for this week. And if you don't have it already, don't worry, it's not that much coding. but the homework is to come up with write a number guessing game where the computer will choose a random number from 1 to 99, and you start guessing numbers. It will tell you if the number is too high or too low, and then it'll stop when you guess the right value, right? And how we want to do this to use what we've learned so far is to do this using functions. And specifically, it should have at least two functions. You could have more if you want, but you have to have at least these two functions. A get input function. And this will prompt the user for input, check if it's valid, and make sure it handles any exceptions, right? And it will return the player's guess as an integer if it's valid and -1 if it's not. So we'll ask the user for input, and if the user types in a number from 1 to 99, it will just return that value. But if the user puts in like ASDF, then it will catch the exception. It will return -1, right? So this is one function. The second function is a give reply function. It takes in a guess, it takes in the real value, and then it prints out a message, right? It will print out either too high, too low, or you win, right? And so these by themselves isn't enough to do the game, right? They're building blocks, right? Once you write these two functions, you have to figure out how to use them to finish the game in itself. And as a hint, you're going to need functions, you're going to need loops. You're going to need input, and I put in Google Classroom how to do the random number thing. But just to end off class, I have a sample solution I've wrote before, but this is what it should look like just as an example. It doesn't have to look exactly like this. These messages, how it works is just how I wanted it to work. You can do it definitely something else. But here, if I just run this, it will give me a prompt. Oh, well, I actually have to run the whole code. So don't look at the code too much. But if I run it now, gives me a welcome message, just keeps asking for guesses, right? So I can guess 7 and it's too low. I can guess 50 and it's too high, right? I can type in ASDF and it knows that that's not valid and it will ask me again. Right? I can type in a number that's not in the range, right? Like 93, or technically that's just 93, but 999, again, that's invalid. So it'll ask me again, right? And so that's how the game should work. And then eventually, once you get the right answer, it'll stop. Maybe I can try to do that. 39 is the correct answer. Yeah, and so it tells me, hey, I wanted 10 tries, right? All these things are up to you, how it works, how it looks, but this is the general thing I'm looking for. Again, please try to get this done by Sunday night, if that's possible. If you have questions on how to get started, or if you get stuck halfway, leave a comment. I'm happy to help. That's all I had for class, though. So if you have any questions, as always, I'll be staying around to answer them. If not, have a great week. I'll see you all next Monday. Yeah. Bye, Jennifer. Bye, Andrew.